Hey guys, welcome back to another show and tell. I recently bought one of these little pan and tilt kits online, and I want to add that to the robot that I'm experimenting with. I figured somewhere on the top I could place this with a camera and then drive that around and view the footage. And I figured, wouldn't it be really cool if I could drive this around my property whilst I'm sat on the sofa behind me watching the video stream through that TV whilst drinking a beer. Wouldn't that be cool? Anyway, so like with all of these things that you buy on AliExpress and Temu, you really do get what you pay for. This one didn't come with any instructions, and annoyingly you have to cut the plastic in a few places to get it put together. And also they don't send you 180-degree servos, they send you 360-degree servos. So when I plugged it in and put some code in, it just kept spinning around and around, and all the cables got tangled up and it was a right mess. So I figured, wouldn't this be a good opportunity to make a video and perhaps help the next person? So stick around and we'll have a look. Right, let's have a quick look at how this is wired together. It's very, very simple, but I'll run through it anyway. So behind here, there are two servos, each with a cable coming out. And there's three wires on that. You've got your ground, your power, and your signal, which is the yellow one. And they go into this. This is a 18650 battery pack. I don't have a proper power supply at the moment, so this is the easiest thing I could find that will give me a stable 5-volt output. So the power and the ground from both of those servos go into these two. There's two sets of pins here, and you can see there's a third one on here if I ever needed it. So that runs my power. And then over here, this is the ESP32. So I don't know how well this is going to show up on the camera, but the two yellow cables coming out here, those basically go to the two yellow cables up here. If I bring that around, you can see yellow to yellow. So they allow me to drive the motors on pin 16 and 17. And then I'm connecting ground to ground, and then ground back to here. You have to have a common ground between all your components, otherwise it won't work. So yeah, make sure you have that common ground. So yeah, very simple. Right, let's have a look at how we put this together then. I went out and bought another one for the purposes of this video so I could pull it apart and show you. And you're probably wondering, why isn't this going together? That will all become apparent soon. So what you're going to need is a pair of snips of some kind. You probably could use a Stanley knife if you want to, just these are much easier. Then you'll obviously need a very small screwdriver, and you're going to need a metal file to file down the plastic, and you're also going to need a 5mm drill bit. I don't know what that is in American. 7/12, 3/9, I don't know, something like that. 5mm basically for normal people. So looking at the base, I've already gone ahead and put this piece in, but you'll notice that the pieces they give you are way too big. They will never fit in there. So if I give you a side by side, my camera can zoom in. So what you have to do is this long side here, you have to trim it down so you've only got two holes. So that's where you use your snips to basically just snip it off. But then, even then, it won't go in because there's too much plastic down the sides here. It's too wide. So what I do is I grab my file, hold it on the bench, and then put it on here, and then just rub it up and down to take away some of that plastic. And you'll have to work at it for a little while, but eventually you'll get it to the right size where it will fit into that groove. And it has to fit into that channel because otherwise you can't screw it down. And then if you can't screw it down, the motor that goes in here won't be able to turn because it will keep catching on those screw heads. So you have to make sure you get it in that channel. So that's modification number one that they don't tell you. Modification number two is that the screws that they give you, I think they're just random screws they've found laying around the warehouse because none of them really fit. You have to trim them as well, which is kind of annoying. So what I did was I took some of these screws. If I hold it with this, you'll be able to see it. My fat fingers won't get in the way. But I took some of these screws and I snipped the end off. So just snip it like that, somewhere about halfway. When you do snip it though, do it on the bench and put your hand over the top, because the bits will come flying off and they'll go anywhere. So do that, and then put those 2 screws in. If you don't snip these screws off, then what will happen is they'll stick out the back here. They'll poke out the back, and they'll poke out much further than the platform itself. So you won't be able to mount it onto anything unless you want to scratch up all your metal, which is probably not what you want to do. So yeah, trim those off and get those punched in. Doesn't really matter which way they go around, just make them opposite, of course, and make sure the screws are all the way in. So that's modification number 2 that they don't tell you about. The next bit is you can grab one of your servos, take the tail, as I call it, and the tail goes this way, because on this side is where the face will be. So you obviously want your tail coming out the back. So with these ones, they're pretty simple. There is a groove at the bottom. The camera's probably not going to focus, but you'll see there is a groove at the bottom, and that just slides over the motor. So do that, and then if you want to, there are some screw holes here, so you can clamp those together. I'd suggest doing that when you're finished. Alright, on to the next modification they don't tell you. The arm up here. So you're going to need one of these single arm things, and again you want to trim it down. This time you want to leave 3 holes rather than 2, and again you have to take material off this edge here, because it'll be too fat to fit in the groove. So yeah, take it down to 3 holes, and then again rub it on the file, and eventually you'll be able to poke it through this hole. And again, that needs to be able to clip in. It will clip, and in my case, because these are pretty crap, it's actually busted the arm, but that's fine. It will still work. So yeah, push that all the way in. I think it's actually the diameter of the white bit is too big for the arm, which is kind of annoying. But anyway, punch that in and then stick a screw in the end one. Doesn't matter if it sticks through. You can trim it if you want to, but this one doesn't really get in the way, so I kind of left it. You might want to trim it, maybe it will catch the wire and fray the wire, but yeah, anyway. So that's modification number 3. This is great, isn't it? How about modification number 4? It's got to be a modification number 4. So the faceplate. So what you want to do is look at the back of the faceplate, and you want to get a second servo, and you slot that in. I don't know if you can see, but you slot that in up against these black plates, and then you can screw that in. Don't do it all the way up, leave it a little bit loose, otherwise you won't get it all together. And again, take the tail back. So modification number 4. So you'll see there's this little knobbly bit that sticks out there, and then you've got this opening here. Now, the way it comes, you won't get that in there. It won't fit. They've made the hole too small for some really annoying reason. So what I did was I take a 5mm drill bit, and then obviously not when the servo's in there, because you don't drill through that, but I just bore out that hole to 5mm, and then what you'll find is that will slide over that hole perfectly. So again, leave that top servo loose, so this way you should be able to squeeze this in. I've probably made it a bit too tight, so let me loosen that up. Kind of fiddly how they did this, isn't it, really? So should almost be able to get that in there. There we go. And then this side. So I've got that on there now, and you can see it moves much, much better. If you didn't bore out that hole, then it'll be very sticky, and the motor might not move. So you do that on this side, and then on the other side, you want to just press the top of the servo through there. So that way, everything should be aligned. And then what you can do is you can tighten up these screws if you need to. The bottom one's a bit hard to get to. You might want to wait until you've coated it all up and then just move the servo back and get the other one. And then lastly, stick a screw into there to hold the servo in. I have been using these ones that have got the wider head on them. They seem to work pretty good. So put that into there, that will hold that. And then last thing is just to plonk that onto the base plate. I can find a way for it to slide in. And then again, you can put another one of those wider head screws in the bottom so it holds it in, it doesn't fall off the base plate. And that's pretty much it. Probably want to poke this wire through so that comes out the back as well, so two tails come out the back. And yeah, that's pretty much it. Okay, let's have a quick look at the code then. So first thing you need to do is go to your settings in Arduino IDE, and there's an option down here to add additional board manager URLs. So if you don't already have BluePad32, you'll need to add that in as an option here. I'll put the link for this down below so you don't have to copy it off the screen. But basically what this does is it points your IDE at an external repository, so you can then go and download additional things that aren't in the sort of base Arduino libraries. So add that in, then go to Boards Manager and search for BluePad32. You'll see this library here, ESP32 BluePad32 by Ricardo Quesada, if I've pronounced that right. But go ahead and install that. It'll take about 10 minutes. And that means that you can then connect all of your Bluetooth controllers. I'm using an Xbox One Bluetooth controller, but I believe this library works for all the major ones. So, you know, PS4s, PS5s, Nintendo Switch, I think, and then maybe some of those, you know, 8-bit retro Bluetooth controllers as well. Go and look on their website. They've got a list of all the support controllers. So when that's installed, if you go under Tools, you'll notice that there's an additional item here now called ESP32 BluePad32. So just go and pick your board. I don't have mine plugged in at the moment, but normally I would use this one here. And by using this option under BluePad32 just means that when you go and deploy your code, it's got all the bits bundled in that it needs for BluePad. So let's have a look through the code. I'm not going to go through every single line because I don't want to bore you to death. Again, I'll put links for this down below, but I just want to point out some things that might be interesting. So yeah, obviously set the pins that you're using. I'm using 16 and 17, but that might be different on your setup. And then we have the stop angles. So let's just talk about this for a second. So with servos, you've got two main kinds of servos. You've got your 180 degrees, so it will go from, you know, from one angle to 90 and then over to 180. So you've got that range of motion. And then you've got the other type, which are 360s. So they'll just keep spinning around and around either direction. So when I bought this, I thought that I was getting the 180s, but I actually got the 360s. So it took me a little while to figure this out. So with the 180s, when you set the value for the servo, you're setting between a range of 0 and 180. And then depending on what you set, it will figure out which angle to set that to. So if you set it to 90, it will set it in the middle. If you set it to 0, it'll be one side, and 180, and then all the values in between, obviously. Now, with 360 degree servos, it interprets that value as speed rather than angle. So it won't go to an angle. So if you put in 90, it's not going to go to 90 degrees and stay there. What it does is you'll have a middle value, which for me is 94, and that's stop. And then if you go below 94, it starts to creep one way. And the further you get away from 94, so the closer you get to 0, the quicker it will go in that direction. And then the inverse for the other way. So 95, it just starts to creep over this way. 96, 97, you get to 120 and it starts spinning a lot quicker. So really 90 should be the stopping point for a continuous servo. But with some of these cheap ones you get from AliExpress, there's a little bit of tolerance in there. So for me, when I had it set to 90, it would still keep creeping around. So I just played around with it and I found that 94 was a sweet spot. So yeah, if you find that with your motors that you've set it to 90 or 94 and it's still slightly moving around very slowly, just play with those values until you get that right. So setup, what's interesting in here, nothing really is interesting there. The only thing I do that when I turn it on is I just set it to that stop angle straight away, just so when I turn it on it doesn't start spinning, you know, it starts stopped, if that makes sense. And then in the loop, what I'm doing here is I'm just taking the values from the gamepads. So I'm using the joysticks And obviously the joysticks themselves, they have a range of motion. So it'll be from minus 512 would be when you pull the stick all the way down, 0 would be in the middle, and then plus 512 would be all the way in the other direction, and then obviously increments between that. So what I do is I basically map those values, to a value that I can send into the servos. So that gets mapped between 60 and 120. And the reason I do that is because I don't want to go all the way to 0 or all the way to 180, because then it just becomes way too fast. So I sort of cut that off between 60 and 120. So I can move it, but it doesn't shoot around too fast. Yeah, and then what I do is I just check the value, map it, and then write it to the servo. Otherwise, I just tell the servo to stop. And I've got a dead zone in here, and you'll notice on the joysticks that sometimes if you move it all the way forward and take your finger off the joystick so it pops back to neutral, sometimes that still triggers a value, so it won't always be 0. Sometimes it might get to 5 or 7. And what will happen is, if you don't have a dead zone, is you'll let go of the stick and the motor will still start creeping. So I put a dead zone in there. What is it, 50? Yeah, so anything less than 50, it will just ignore. Yeah, and then I do the same thing for the other motor. So I do one for the panning, which is turning around, and then one for the tilt, which is up and down. And then I just print those out to the console as well, just so I can see what's going on. And that's it, pretty much. That is pretty much all I do. So you should be able to take this code, dump it in, and off you go. I hope that was useful for someone. I couldn't find this information when I first started. Maybe it was too obvious and people didn't talk about it, but it took me a little while to figure out, first time using this. So yeah, that's all for now. Remember, stay curious and keep learning, and I'll see you in the next one.